Greetings, geometry students. Today we're going to take a look at a very important concept to the idea of graphing, and today's topic is that of slope. Please copy down the title as well as today's objectives. The stated objective is the student will discover the process and applications of the slope formula. With any luck, you remember having worked with slope before in your discussions of the slope-intercept form for graphing a line. The student will demonstrate the ability to utilize the slope formula while completing another class activity. And the essential question, can I find the slope of a line in a graph? Now there's a lot of information to cover as we go through the topic of slope, so bear with me as we discuss several different aspects of it. As always, press pause anytime you need more time to copy something down, and then press play when you're ready to move forward. Let's get started. Now, slope-intercept form, which is going to be the topic of discussion for the next couple of days, is the equation y equals mx plus b. Hopefully you are very familiar with this format. In this format, a line needs two things in order to do what it does. The first thing a line needs in order to do what it does is it needs somewhere to start. Obviously, if we're going to start drawing a line in a graph, we have to know where to put our pencil on the paper. That is somewhere to start, and then after that, we need somewhere to go. So number one, somewhere to start. That is actually your y-intercept value, the b from y equals mx plus b. This tells the line exactly where it's supposed to cross the y-axis. So in essence, the b value is what fixes our line in two-dimensional space in the Cartesian coordinate graph. The second thing our line needs was somewhere to go. After we leave the y-axis, we need to know which direction to go, how fast to move. That is all accomplished by the slope of the line, which is m from the slope-intercept form, y equals mx plus b. So basically, when you have your equation in slope-intercept form, m is the coefficient, or the number in front of, the x variable. We're going to be spending our time today looking at the m value, what it means to a graph. Okay. Now, m tells the line in what direction to move, how fast to move, as it leaves the y-axis. Now, when we talk about the direction for it to move, that means it could move upward as we read the graph from left to right. It could move downward as we move the read the graph from left to right. It could be moving very, very quickly, which means it's very steep and heads off the top of the graph or the bottom of the graph in a big hurry. Or perhaps it's very shallow, meaning it moves more sideways than it does upward. So it would maybe move off the left side or the right side of the graph. Okay, so we'll learn to read the slope value in order to understand what it has to tell us. Okay, now let's just talk about several synonyms that exist in or surrounding the term slope. Okay, so there's many ways a question can ask us for the slope value of a line. All of these have the same meaning, but here we go. Obviously, a question could ask us for slope, but that's a little obvious, so it's pretty unlikely that a question is ever going to come out and ask us to find the slope of a line. That's more of a high school or a junior high school vocabulary term. M, lowercase m, is the algebraic representative for the idea of slope, as in y equals mx plus b. Okay, keep in mind that graphing is an algebra skill, not a geometry skill. M in geometry typically means measurement. However, graphing is algebraic, and in algebra, lowercase m means slope. You may remember these vocabulary terms from back in the day in junior high school. Rise over run was probably the way it was explained to you by your junior high teachers when you were first getting a mental grasp on the idea of slope. So they could say rise over run, but again, these are very elementary terms, so we probably wouldn't see these terms actually worded this way in a high school type question. Okay, instead of putting rise over run into verbal form, like the orange one shows there, they could put it in ratio form, like the purple one shows there, rise over run. They could write it like a fraction. But again, probably not very realistic to hope that a question's going to ask for it in that format. Okay, this gray one that just showed up there, that is actually the formulaic way that we find the slope. So there are the familiar x1, x2, y1, and y2 values that we have seen in recent days dealing with our points from a graph. And the slope can be found by, in 2 points, finding the y2 minus y1, and then dividing that by the x2 minus x1. Putting this value or this idea into verbal form, that would be the change in the y value over the change in the x value. Subtracting the two y values in the gray ratio there on the left, that is basically measuring the change in the y. In the denominator, okay, subtracting the two x values, that is the change in the x. So obviously change in y over change in x. That says the exact same thing that the slope formula there in the gray says. It's just in verbal form. Looking at it in a more mathematical format, we could look at this one, which says delta y over delta x. That triangle means delta, and if you have studied any physics or possibly even any IPC, delta is the Greek alphabet letter that is assigned to change. So that black ratio there says change in y over change in x, which is exactly what the green verbal statement said on the upper right above that, which of course says the same thing as the gray does. These all mean slope. And the common kind of everyday flavor of the month way of asking for slope these days has been the vocabulary rate of change. So a lot of times we've seen it in the last few years when they have asked us for slope, they have not used many of the other formats that you see on the screen there. They have used the term rate of change. What is the rate of change of the particular function that we're talking about here? They have been asking for the slope. Unfortunately, we have little knowledge of how they may ask a question, so it's important, as always, to know all of the synonyms so that no matter how they ask for it, we will know exactly what they are talking about. And all of these formats mean the slope of the line connecting 2 points. And those 2 points, just like they have been in recent days, are point 1, which live at x1, y1, and point 2, which live at x2, y2. Okay, so let's move forward. Now, let's just kind of dispense with the obvious. Slope is a fraction. Okay, well, everything in mathematics is a fraction. Every value is a fraction, even if it is written as 1 or not. Okay, remember that every value has a denominator. Even if you did not write a denominator, Okay, the denominator is always over 1 if it was not written down. And a lot of information can be determined just from observing the slope value in an equation of a line. And it's time for us to understand exactly what the slope value is telling us rather than just having to graph it and look at the line itself. Okay, so let's look at some of the properties that a slope value may have. If the slope value of the equation of the line is, first off, positive. Okay, so the slope fraction, whatever it is, if it is a positive value, this means that the line will move upward as you look from left to right in a graph. Okay, this is the way we read our graphs. If we have a choice, we always try to read them from left to right, just like you are reading a sentence. Okay, so as far as a graph is concerned, if a line is moving through this graph and you know that the slope value of it is a positive value, that means the line is moving upward as you read the line from left to right. It does not mean that it is going to be a steep line or a shallow line that is rising in a hurry or very slowly. It simply means that it is rising up if it has a positive slope value. Okay, or perhaps your slope value in your equation of your line is negative. If the slope value of the equation of the line is negative, this means that the line will be falling. It will be moving downward as you read the equation from left to right, moving through the graph. Okay, so looking at a graph, if you're looking at an equation and you see that it has a negative slope value, a negative m value, that means that the line will be falling as you read the line from left to right, moving through the Cartesian coordinate plane. Once again, it does not mean that it will be falling quickly or falling slowly. It simply means it is moving downward as you move through the graph from left to right. Okay, a couple of more pieces of information can be told from the slope. Let's say that the slope fraction is a value larger than 1, meaning the numerator is larger than the denominator, like 3 over 2, 5 over 3, 7 over 4, things like that. When this happens, what it means is the numerator, which represents the change in the y values, is bigger than the denominator, which is the change in the x values. Essentially, it means the line is rising faster than it is running. When this happens, it means the line is moving upward or downward, depending on whether it's positive or negative, very quickly. So in a graph, when you see a line that has a slope value that is a value larger than 1, that means that the line is going to be very steep within the graph because the rise is moving faster than the run. Looking at the converse of that situation, perhaps we have a slope value that is smaller than 1. Now that will happen when your numerator is smaller than your denominator, like 1/2, 2/3, 3/6, 4/10, stuff like that. That means that the run, the denominator, is actually bigger than the numerator. So a smaller rise but a larger run. That means that the line is moving upward or downward more slowly. In a graph, a line that has a slope value that is smaller than 1 would tend to look more flat. Okay, so these are pieces of information that we are expected to know about a line simply by reading the slope value of its equation. Okay? Now, let's say that we look at a slope value and we come across a situation where a line will run, meaning its denominator is moving, but it refuses to rise. So the numerator's value is actually 0. As we move from one point to the next point, the numerator did not change. When this happens, basically we have a slope fraction that has a 0 as a numerator. And hopefully we know by now, if you have a fraction with a 0 as a numerator, that makes the value of the fraction 0. When that happens, we say that we have 0 slope, and the line will be horizontal. Okay, so when this happens, obviously we have a line that refuses to rise, but it definitely does run. We say that this is 0 slope. Now, just a little side note, in case you have a teacher that may have some outdated information in your junior high past, some teachers are still using the term no slope to describe this situation. And within the last half a decade or so, it has been determined that this is an inaccurate term. And if you have learned no slope for a horizontal line, you need to remove that vocabulary from your memory and instead start identifying these lines as 0 slope. Now let's say we have a slope value such that the line rises, but it refuses to run. If that's the case, then we are getting kind of the opposite situation of what we just discussed. The line has undefined slope, and the line will be vertical. Now let's take a closer look at this. Okay, so the line is rising just fine, but it refuses to run. So basically what this is saying is as you move from one point on the line to another point on the line, the rise is changing, but the run is not. That would put a 0 in the denominator of our slope fraction. And hopefully we know that having a 0 as a denominator of a fraction is a situation that we refer to as undefined fraction. And if it is a slope fraction, then basically we just call it undefined slope. And another situation they may run into is the infinity symbol. And if you're not familiar with infinity as a symbol in mathematics, it basically means uncountable. Okay, so either of those terms would be acceptable to describe the slope of a vertical line. Okay, now let's look at the calculations here. The calculations are not very difficult. There's just a lot of information that we had to cover before we could get to the calculation. So what is the slope of the line connecting points -2, 3 and 6, 7? We are going to employ the same strategies that we have all along in this part of this unit. The first thing we are going to do is we're going to take our 2 points, -2, 3 and 6, 7, and we are going to label them. One of them is going to be point 1, which will be labeled as x1, y1, and point 2 will be labeled as x2, y2. As has been the case throughout this part of the unit, it does not matter which point is point 1 and which point is point 2. Simply get them labeled. The other strategy that we have employed all along is we have a formula, and we will write that formula down before we plug any information into it. The slope formula is m equals y2 minus y1 over x2 minus x1. Putting that into verbal form, that is the difference of the y's over the difference of the x's. So we're going to take our formula and we're going to plug in the information. The formula asks first for y2. y2 in this case is 7, so we're going to plug it in. Then it says to subtract from that y1, which is 3, so we're going to plug it in. Then the formula says to divide that by x2, in this case is 6, and to subtract from that x1, which in this case is -2. Now we need to simplify both the numerator and the denominator before doing the division between the two. In the numerator, 7 minus 3 is 4. And 6 minus negative 2, well, the double negative right there becomes a positive, so you have 6 plus 2, which is 8. Slope is supposed to be a fraction, but we do reduce it wherever possible, and 4 over 8 does reduce to 1 over 2. There is absolutely no need to turn this into a decimal point because we actually need the fraction. The numerator means something to the line. That is the rise. The denominator means something to the line. That is the run. So we want to leave this as a fraction. This would be the slope value for this line. Now, tying back into the information we just talked about, what do we know about this line based upon its slope? Well, the first thing we should recognize is that the slope value we are looking at there is positive. What does it mean to have a positive slope value? That means the line is rising as we move up, or as we read from left to right. So the graph is moving upward. Secondly, 1/2 is a value that is smaller than 1. So we have a slope value that is rising slower than it is running. That means the graph is moving upward more slowly than a typical line. Okay, simple calculation, just a little bit more information talking to us about what that value means. Okay, let's look at another one. What is the slope of the line connecting points -4, 7 and 0, -5? Going to move through this one a little bit more quickly. Okay, same strategies. Take your 2 points and label them. One point is going to live at x1, y1. One point is going to live at x2, y2. And it does not matter which one is point 1 and which one is point 2. We are finding the slope value, so we're going to write down our formula. M equals y2 minus y1 over x2 minus x1. Now all we have to do is plug in our information in the appropriate places. Y2 is -5, y1 is 7, x2 is 0, and x1 is -4. Simplifying the numerators and the denominators, -5 minus 7 is -12. 0 minus -4 is +4. 12 divided by 4 is 3, and negative divided by positive. With multiplication and division, if the signs are different, the answer is always going to be negative. So our slope value is -3 over 1, or simply -3. And you might actually choose to leave that as a fraction because, again, with slope, our numerator means something and our denominator means something also, rise over run. So it could be written as -3 over 1, but a lot of times they will remove that denominator because over 1 does not actually change anything. So they would simply say the slope is -3. Just remember that that means that there is a 1 in the denominator, because that's always the case if they do not write any denominator at all. Okay, so what do you know about this line based upon its slope? Well, first off, we have a negative slope. That means as we read the graph from left to right, our graph is falling. It's moving downward. And -3 over 1, this is a value that is definitely bigger than 1, so our graph is definitely rising or falling in this case as it faster than it runs. That means it is falling quickly. Now, one more quick example, not that I think you haven't figured out the math, but there are some special cases to consider. What is the slope of the line connecting points 3, 2 and 3, -1? Well, let's take a look at this one real quick and see what it does and why it's so much different from the others. Same strategies still apply. Take our 2 points and label them x1, y1. x2, y2. Record our formula. M equals the difference of the y's over the difference of the x's. And plug in our values. Okay, so in this case, y2 is negative 1, y1 is positive 2, x2 is positive 3, and x1 is also positive 3. Now we're going to simplify in the numerator and simplify in the denominator. In the numerator, negative 1 minus 2 is negative 3. In the denominator, 3 minus 3 is 0. Okay, we have just run into a problem. Our slope fraction has a denominator that is 0. That means our slope is undefined. So at this point, what we need to do is determine what that means to the line. Well, we have a slope that is rising. Actually, it's falling, negative 3 in the numerator. However, in the denominator, we have a 0. So our line is refusing to run. That means the x value is not changing. So the y value is changing, but the x value is not. So what do you know about this line? It will not run. That means this line is actually a vertical line. And this is one of the special cases where we end up with a 0 as part of our slope fraction. The only cases where that happen are horizontal lines if the numerator is 0 and vertical lines if the denominator is 0. Okay, so that's a lot of information to absorb about slope, but as you will come to see, if you haven't figured out already, a lot of information is controlled about the line based upon the slope value. The y-intercept is a lot more simplistic. We will be looking at it along with the overall equation in the next lesson. Jot you down a summary. Scribble down any questions that you may have that you need to come in for tutorials and get answered. And always keep in mind your essential question. Can I find the slope of a line in the graph? I apologize that the notes are a little bit longer than usual tonight, but again, a lot of information for us to take in. I will see you in class.